We're going to learn how to graph linear functions using intercepts. So intercepts might be a new vocabulary term for you. Let's take a look at a graph of a linear function already. So here's our straight line, which tells us that we're dealing with a linear function. And the intercepts are these 2 points right here. Here's our x-intercept, and here's our y-intercept. And the x-intercept is the point where the graph of this function intersects with the x-axis. So this is where the line crosses the x-axis, and x-intercepts look something like this. They have an x value, and their y value is always 0. So the x-intercept is a point with some x value and a y value of 0. And our y-intercepts are just the same, but for the y-axis, where this graph intersects the y-axis. And they look like they have an x value of 0 and some y value. So they always look like this. If we're asked to graph this equation, 4x plus 5y equals 20, you'll notice this is in standard form. And this is one of the uses of standard form, is that we can use this equation to graph by intercepts. So here's our coordinate plane. And remember, we only need 2 points to graph a line, so having an x-intercept and a y-intercept is great because I know at some point almost every line will cross the x-axis unless it's just a horizontal line. So our x-intercept will be somewhere along the x-axis. We just need to find out where. Remember, x-intercepts look like this. They have some x value, and they always have a y value of 0, meaning we can just plug in 0 for y and solve for x. We can always find the x-intercept this way. So when I take my regular equation and instead of writing y, substitute in 0, I can simplify this just a fair amount, end up with 4x equals 20 because, 5 times 0 is 0, and I don't need to write plus 0 to anything, so I can take that part away. And now all I need to do is divide each side by 4 to solve for x. So when y equals 0, when we plug in 0 for y here, we get an x value of 20 divided by 4, or 5, meaning we have our x-intercept, which our x value is 5 when our y value is 0. So I get to plot this point right here. This point is 5, 0, and this is our x-intercept. Now on to finding our y-intercept, and you might well guess that this is going to be found along the y-axis like we talked about before. It's going to be some y value where our x value is 0 because it looks like this. And so what you might have guessed is that all we need to do here is plug in 0 for our x value to find this y-intercept point. So we're going to plug in 0 for x, meaning that first part, 4 times 0, can go away. We don't need to write plus 0. So we end up with 5y equals 20, and all we need to do is divide each side by 5. And we'd end up with y equals 4. So when x equals 0, y equals 4. So we have a point, 0, 4. We can plot this as our y-intercept. And here's 0, 4. So now that we've found both our x and y-intercepts, let's pause and review what we've done so far. So we've plugged in 0 for y to find our x-intercept. And we've plugged in 0 for x to find our y-intercept. And now that we have 2 points, all we need to do is graph this line, meaning take our straight edge or ruler or computer augmented straight line drawing tool and just draw a line that connects these 2 points that goes straight. It goes on forever in both directions. And this is the graph of our original equation, 4x plus 5y equals 20. You can do this for any linear equation in standard form, and this is why we like standard form.